in this case we have been asked to calculate the number of collision domains and broadcast domains. Let's do a quick recap on collision domain. So collision domain is a segment of network where only one device can talk at a given time. So in this setup, say let's take a quick setup here where we have four devices connected to via a hub. Now in this setup only one of these four PC can talk at a given time. If more than one PC talks or starts talking, those packets end up colliding with each other and resulting in failure of communication. Now so in this setup this is one collision domain. So it is one collision domain that has four PCs in it. Now let's connect two hubs to each other. Now we have six PCs connected to each other, but in this case also only one among these six PCs can talk at a given time. So we have slightly bigger collision domain. Therefore we can say that connecting two hubs results in increasing the collision domain. So regardless of how many connections are coming out of the hub results in one collision domain. Okay, now let's replace the hub with a switch and see what happens. So if we replace this with a switch, now with the switch any two devices can talk to each other without affecting the communication between any other guys. So PC A can talk to PC B without affecting communication between PC C and D at the same time. So there will never be a collision when a communication is happening between any two given host. So in a sense each connection is its own collision domain. So this is one collision domain, three collision domain, four collision domain. So we have, since there are four hosts connected to the switch, it will result in four different collision domains. So when we use a switch instead of a hub, the number of collision domain increases. And also to note that the size of the collision domain does decrease. Earlier with the hub we had one collision domain with four hosts, but in this case we have four collision domains with one host in each. So the size decreases but the number of collision domain increases. Now let's talk about broadcast. So broadcast is a way of communication where one device can talk to multiple devices at the same time. So it's assuming so think of it as a classroom full of students where one teacher can talk to all the students at the same time. That in that setup the class is the broadcast domain. So for example let's assume all PCA through PCD are IP'd out of same network address or within the same network address. Now in that case PCA can directly talk to PCB, C and D at the same time using one single packet. So in that case this is one broadcast domain. Okay, now let's connect this switch to another switch. So to a switch another switch, and assuming E and F are also IP'd out of the same network that PCA through PCD were. So in that case if PCA sends a broadcast message, the PCE and PCF will also receive it. Therefore this is a new broadcast domain. So connecting two switches increases the size of broadcast domain. Now let's connect these switches to a router. Okay, so if we connect these two switches to a router on this side, now we know that these two networks or these two segments cannot be on the same network, right? Routers cannot have two interface on the same network, so we have to use different networks on each side. 10.10.10.0/24. Let's say this is the network address on this side, this on 24, and on this side it's 10.10.20.0/24. So this is the network address on this side. So now PCA can send broadcast message to B, C, D and the router interface over here, and also PCE can send a broadcast message to this interface on this router and PCF on over here. So we have one broadcast domain and another broadcast domain, so two broadcast domains. So since there are two networks connected to a router, that means we have two broadcast domain. Okay, so the idea or the conclusion here is, with hub, if we use a hub, it extends collision domain. Collision domain switch, it breaks collision domain and extends broadcast domain, and router breaks broadcast domain. Okay, so in a router, the one broadcast message can never pass through a router and go to the other side. That will never happen. The broadcast messages are the maximum point broadcast message can reach is a router. Router will never ever in any case forward a broadcast message to the other side. Now let's go back to the diagram here, or to the question. Now here let's just calculate our broadcast address and our broadcast domain and the collision domain in this case. So in this case, let's say, since let's first calculate the collision domain. So on this side there is a hub. So regardless of number of connections connected to a hub results in one collision domain. So there is one collision domain on this side, one collision domain on this side, and also there is a switch here on this side. So on a switch, each connection acts as a collision domain. So 1, 2, 3, 4, 5 and 6. So 1, 2, 3, 4, 5, 6 and 7. So we have total 7 collision domains. Let's note it down. Seven collision domains, and here we can see there are two networks coming out of the router. So one side, this is one, and the other one is this. So this is there are two collision. No, there are two broadcast domain. So let's mark that two broadcast domain. So now once we know that, let's review our options and see which one are the correct answers. So there are two broadcast domain in the networks. That is correct. There are two broadcast network in the broadcast domains. There are 4 broadcasts. That is not correct. There are 6 broadcasts. That is also not correct. There are 4 collision domains. We have total 7 collision domains. So that is not correct. 5 collision domains, and there are 7 collision domains. So these are the two correct answers. Okay. Now let's review one more questions which is similar in nature. So in this scenario, we have a diagram with a hub connected to a network, and the question is, if we replace this hub with a switch, what happens? So let's just calculate the number of collision domain and broadcast domain with the hub, and then we'll later do it with the switch and see what happens. Okay, so with hub on it, we know regardless of the number of connections coming out of hub, as soon as there is a hub, it results in one collision domain, right? So let's just say note it down. Collision domain with hub is 1, and since there is only one network connected to the router, this will result in one broadcast domain. Now let's replace this with a switch. So when we replace this with a switch, each connection on a switch acts as its own collision domain. So this is 1. So this is 1, 2, 3, 4, 5 collision domains. So we have 5 collision domains when you use switch, and in that case also there is only one network address used here, right? There is only one interface connected to this network on the router side, so this still has one broadcast domain. Okay, so when we switch or when we change a hop to a switch, the number of broadcast domain remains same, whereas the number of collision domain increases. So we know that now, and let's review the options and see which one is the correct answer. So the number of collision domain would remain the same, that is incorrect. The number of collision domain increases. The number of collision domain decreases, that is also incorrect. The number of collision domain would increase, that is correct. The number of broadcast domain would remain the same, that is correct. Our broadcast domain remain 1 from 1 to 1, so this is also correct. Since there are only two correct answers, rest of them are incorrect. I hope that explanation was helpful. Thank you.